or afternoon or whatever it is at the time of your watching this. It's actually night while I'm recording this. So, um, how are you all doing? Hope you're having a good day. Sorry I can't be with you today, but I'm on my way or am already in Oklahoma City for a coaching conference. So, you get to do some math today without me. Hey, it's not a bad lesson today. It's pretty. I really think you'll find it fairly simple. That's my honest assessment. I don't think you'll have too much trouble with today. You need to be on page 195 of your book. It is lesson 3.5. If you're not there yet, go ahead and pause the video and get there so that you can follow along. You know the routine. Have your books open and follow along and get the notes taken down and pay attention. There's just a couple of vocabulary things really today to talk about that relate to things that you already know how to do. So it's just a little shift in some vocabulary in the way that we look at graphs really is the kind of what's going on today. They'll introduce some new vocabulary for you in the video today. For the warm-up, it's a pretty simple warm-up today. Martin will ride his bike from his house to his aunt's house. He has two different routes that he can take, and you can see them in the picture. One route goes up and down a hill. So there's the hill. It goes up and down the hill. And then the other route avoids the hill by going around it. So there's the route around the hill. How do you think the routes will differ? Well, I'll let you think about that. You guys are way better at riding bikes than I am. I haven't ridden a bike in a long time because the last time I rode a bike, I ended up in the hospital, and that was before you all were even born. I don't ride bikes. They're not my friends. So anyway, the route avoids the hill, which means you don't have to do all that work of pedaling up the hill, but then you don't have the fun of going way down the hill either. So it does that. Going around the hill is going to be a more consistent, constant rate of speed, but it's a longer route. So which would you rather have? A shorter route that makes you pedal up and down a hill, or a longer route that gives you just kind of a consistent, easy ride all the way around? What do you think about the relationship of speed and time? If you were thinking about riding this bike, here your speed going up the hill would be slow. But then when you got to the top of the hill, it would kind of level off for a minute, and then your speed would level off for a minute. And then as you went down the hill, your speed would really increase. And you'd go really fast there for a few minutes. Here, your speed would stay pretty constant all the way around the hill. Just some things to think about that really sort of set up what we're going to be talking about today as far as graphs. So how does changing the shape of what you actually do in real life change the shape of what the graph of that activity would look like? Okay? Oh, look, a video. So I'll just play the video. I'm probably not going to have a whole lot of commentary in the video today as we go through it. It will be pretty self-explanatory. Here we go.
How does a qualitative graph describe the relationship between quantities? Think about this question during the lesson. An express train reaches its travel speed of 150 miles per hour shortly after leaving the station and travels at this speed for an extended period of time. What would a qualitative graph of the distance the train travels over time look like? Once the express train reaches its travel speed, what is the relationship between time and distance?
So that phrase he's using several times, a qualitative graph, he's going to explain what that means in the next section of the video. So here it goes.
We can draw a qualitative graph. It's a little different from the graphs you've drawn before. A qualitative graph represents the relationship between quantities without numbers. You begin by identifying the input variable, which is time, and the output variable, which is distance. We also need to identify the intervals. An interval is the period of time between 2 points of time or events. The first interval on the graph begins with the train standing still and ends when it reaches travel speed. The second starts when the train reaches its travel speed. In which interval will the graph be steeper?
Select your answer.
Okay, so a qualitative graph, he says, is one that doesn't use numbers. So time, does this minutes, is it seconds, is it hours? It doesn't tell us, and it doesn't really matter. Is this, an hour of time and this 5 hours of time? Or is this 1 minute of time and this 5 minutes of time? Or is this part 5 minutes and this part 10 hours? It really doesn't matter. And we have to kind of use our imagination about what that time represents, and it's okay. Distance, are we talking feet or miles or hundreds of miles? We really don't know, and it doesn't really matter. What we're thinking about is, what is this graph going to look like as it represents when time is passing, what's happening to the distance of the train. So the question is, which one of these will be steeper? Well, as the train leaves the station and is getting up to speed, it's not going to be moving very fast at first, and then it gets faster and faster and faster. But then once it's up to its top speed, that's where the graph should be the steepest, because it's moving at its fastest speed over this interval. So an interval is a section of a graph or a piece of the graph, and they're going to use this word over and over again in this lesson today. So an interval is just like one piece of the total. All right, so we're going to say this is the steepest.
Now let's determine the relationship between the two variables during each interval. At the beginning of the first interval, the time and distance are both 0. The express train starts moving at a speed less than the travel speed. The distance increases as the time increases. The second interval starts when the train reaches its travel speed of 150 miles per hour shortly after leaving the station. The distance continues to increase as the time increases. Since the train is traveling faster in the second interval, the graph is steeper in this interval.
There we go.
As time increases, the distance the train has traveled increases. The function is increasing in this interval. Once the express train reaches its travel speed, a qualitative graph of the distance the train travels over time is a straight line. Now you know how a qualitative graph can describe the relationship between quantities.
Okay, so the whole point of this lesson is to identify increasing and decreasing intervals on a graph. So as you
can describe the relationship
as
between
you are
quantities.
looking at this graph, both of these sections are increasing, because as time goes up, distance goes up. As time goes up, distance goes up. So they're both increasing, but this one is increasing at a faster rate. It's increasing quicker. So both are increasing, but one is faster than the other. All right, back to my other program here. Okay, so the next part of your book, the next example, this graph shows another interval in the train's travel. Notice now that we're not talking about distance, now we're talking about speed. So as time increases, what is happening to the speed of the train? Okay, and we're always going to read graphs from left to right. So anytime time is on our x-axis, we're going to be talking about as time increases, because time is always going to be moving forward. So we would say as time, I got to be able to write here, as time, whoops, sorry, everything shut down on me. There we go. As time increases, the speed of the train is, what's happening to the speed? It is decreasing. It's going down. Speed of the train decreases. Therefore, the function is decreasing. So now we have seen two different examples. We've seen an example of a graph, a qualitative graph, where the interval is increasing. That was the last graph we looked at. And so if you think about what that graph looked like, the time was going up and the distance was going up, and then it went up at a faster rate. So we saw two periods of increase. Now we see a period of decrease, or an interval of decrease. Guys, we're just identifying positive and negative sections of the graph. This shows a positive relationship. As time increases, distance increases. This one shows a negative relationship. As time increases, speed is decreasing. So increase and decrease just means positive and negative. This is a positive section. Increase is a positive graph. Decrease is a negative graph. Okay? It's that simple. And that's really the bulk of what we're doing today. The graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval. Well, I've got two intervals of the graph, and you can picture what's happening. As he kicks the ball, time is progressing. Time is moving forward, as it always does. And what's happening when he kicks the ball to the height? Well, the height is going up. So in interval one, interval one is increasing, because as time increases, the height increases. And then the ball reaches the top of its flight and it begins going back down. Time is still increasing, but now the height of the ball is decreasing. So interval two is a decrease. Interval one is increasing, interval two is decreasing. That's it. That's all we're doing today. Or that's all we're doing at this moment, I suppose. Okay. This graph shows the behavior of Skyla, I don't know, whatever, skateboarding at a skate park. In which interval is the function increasing, decreasing, and constant? So now we're going to talk about a constant interval on a function, which is a little bit different than the way we've been using the constant. We've been talking about constant rate of change, which could be a positive rate or a negative rate or no rate at all. It could be constant in all those things. Now we're going to talk about constant as though there is no change on to the quality of the qualitative interval of the graph. So in interval one, which would go from here until there is the beginning of interval two, which would be right here, we would have a decrease. It's going down. And picture Skyla dropping in to the ramp on the skate park, right? So she drops in and goes down the ramp. At interval two, which is a short interval, Skyla is on the ground level. So here we have a constant. This part would be constant. There's no change in Skyla's distance above the ground. Skyla is on the ground. And then we have the next interval, which goes from here up to the top here, and that is interval three. In interval three, Skyla is increasing. And then interval four goes straight into a decrease. So we would have, if we were identifying intervals, interval one is decreasing, interval two is constant, interval three is increasing, interval four is decreasing. That's it. That's what we're doing. Okay? So identifying those parts of the graph where it increases, decreases, or is constant. Okay, next example. In which intervals is the function increasing, decreasing, or constant? Well, intervals where it is increasing would be interval one, it's going up. Interval three, it's going up. So increasing would be 1 and 3. Decreasing, can you see it? Do you see where the graph is going down? Graph is going down in interval 5. So it's decreasing at interval 5. And where's the graph constant? Well, there's no change in distance. There's no change in distance in intervals 2 and 4. Okay? So increasing 1 and 3, decreasing 5, constant 2 and 4. It's that simple. I don't know how else to make it any easier. This part is interesting. Write a scenario that the graph could represent. So you're going to have to use your imaginations a little bit. Here's the thing. It doesn't have to be a brilliant story, and it doesn't have to be super detailed. Remember, we're not talking about quantities of time. I don't care how many hours you picture in your mind. I don't care if you see this graph as being 10 hours or if you see this graph as being 1 hour or if you see this graph as being a half hour. I don't care. The quantity is not what I'm after. I don't care if you see this as being hundreds of miles or less than a mile. It doesn't matter. What matters is making a scenario that fits the shape of the graph. So here's my scenario. Billy is going to jog to the park and back home. He starts his jog leaving his house, stops to talk to a neighbor and pet their dog. So he's getting further away from his house in interval 1. He stops, time keeps going, but he stops his running, so distance is not changing, and stops and pets the dog and talks to the neighbor. Then he runs faster because look at interval 3. Interval 3 is steeper than interval 1, right? So he's still getting further away from his house, but he's going faster. Then he sprints the rest of the way to the park. At the park, he sits on a park bench and rests. And then he sprints home all the way. Okay? Now, is the park a block away from his home, or is the park 5 miles away from his home? I don't know. I don't care. Is he running for 30 minutes total, or is he running for 3 hours total? I don't know. I don't care. That doesn't matter. What matters is he's getting further from his house. He pauses. He gets even further from his house. He pauses again. Then he runs all the way home. That fits the shape of the graph. That's good enough. Okay? You don't have to be super detailed. You don't have to write up, 14 sentences. Billy runs to the park, stops to pet the neighbor's dog, runs the rest of the way to the park, sits on a park bench to rest, and then runs all the way home. That's good enough. Okay? You can describe the relationship between two quantities by analyzing the behavior of the function. This is the wrap-up slide. This is the review at the end. You can describe the relationship between two quantities by analyzing the behavior of the function relating quantities in different intervals on a graph. So the function is increasing here. The function is constant when it's horizontal. The function is decreasing when it's a negative relationship or when the graph is going down. That's it. That's what we're doing. You have an assignment, of course, pages 199, 200 in your book. If you finish that, turn it in. If you finish, you can go to IXL and work on the skills that you're assigned. IXL, we haven't been on there in a while. If you remember IXL, it is, not that screen. It's this. You go here, and the skills, I've got from lesson 3.3, lesson 3.4. They don't even have any skills for this one. It's so simple, so I can't even assign any from today's lesson. But if you go back and review lesson 3.3 and 3.4 on IXL, those are the skills that I've assigned you. So you can go back and work on some of those linear, nonlinear function skills. Okay, I will be back to see you on Tuesday since you don't have school Monday. Stay warm. Enjoy your weekend and enjoy your day off. Happy Martin Luther King Jr. Day on Monday. See you guys Tuesday. I'm out.